that is a barrier again. We hit another
Right,
barrier.
right.
But you have a different approach, right?
Right. And it's, obviously full disclosure, it's not my approach. It's definitely something that today is actually very common in it. And like, we talked in the past is probably the most sought after implementation of generative AI. And a lot of people have quoted that 2024 will be the year of retrieval augmented generation.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, an introduction to GenAI RAG models with AI Solution Architect Eduardo Alveraz from Intel. Eduardo, welcome to the show.
Hey, Darren, how's it going?
Hey, this is a really fascinating topic, what we're talking about today about generative AI. Of course, this is part of embracing generative AI. But before we dive into that, Eduardo, tell my audience a little bit about yourself. They all like to hear our backstories. So what's your backstory, Eduardo?
Sure, yeah. Actually, my background, when I went to school for a degree in geophysics, I started out my career in the energy industry. As a geophysicist. My first actual 6 months of my career were as a field geophysicist, stomping geophones, designing acquisition arrays for subsurface imaging. And that was a lot of fun. Very, as you can imagine, data intensive, which, eventually after I finished my 6-month stint out in the field, came back into the office as a full-time analyst of geophysics data. At my time at that first company, there were a lot of data challenges. Data science was still kind of a very new thing from the perspective of the more modern applications of machine learning. So I was very intrigued by trying to solve some of our challenges using some of those technologies, back then mostly traditional ML. It was really right around the same time when neural networks were starting to pick up a lot. So started playing around with neural networks, made a pivot over to an energy tech startup where I eventually ended up leading a team to deliver some software as a service applications for drilling optimization, for geothermal, and for oil and gas wells. Also subsurface 3D modeling using neural networks as well. Then eventually eventually made it over to Intel about a year and a half ago. So it's been a great ride so far at Intel. Had a phenomenal time. Really, I can't imagine a better time to be working on AI. So definitely the career trajectory has been really fun. I always say it's like having my hand super glued to the side of a rocket. Because you're like, I don't know if I want to let go. There's definitely something holding me to this, tying me or tying me to this journey that just keeps me there. It's hard to describe what it is because obviously it's very hectic every day. It's something new, very difficult to keep up
exciting.
with.
Yeah, no, it's that adrenaline rush, right? Of being on the front of the wave. Yeah.
Yeah.
So
really
wait, I gotta tap back.
Go
You were in the field. That means you were out digging holes in the desert.
No, well, I guess you could say, actually, I don't know if West Texas is fully classified desert, but definitely feels like
it's pretty close to desert. Yeah.
Yeah.
So that's a big change from being out in the field digging holes to now sitting behind a desk every day, especially at Intel. We're never going to dig holes at Intel.
No, yeah, I mean, that's a good point. Well, the start out there is really part of this, almost like this. When you joined the company at that time, the company was called Microseismic. You basically spent 6 months out in the field to understand how to work hand in hand with the operating companies. So working with major companies like Shell and Hess and ExxonMobil and many other smaller operators in Texas, in Oklahoma and New Mexico. So I was driving around, going to different what they call frac pads, and sitting in the truck with the different company men and interacting. It was a phenomenal experience. I was very grateful for it. And actually, my colleague today, who is my manager, is one of the people I used to work with back at that company.
Oh, that is hilarious!
It's really So we've reconnected back here at Intel. We've done some really exciting and fun things, both at that company and now at Intel. But
So did that give you a better perspective being out in the field working with the data collection? Did
oh
that give
yeah,
you a better feel for the value of the data that you were then working with back in the office?
absolutely. I think an appreciation for the data environment that I acquired in the field. I never thought about it that way, but has kind of carried on through the trajectory of my career in AI and machine learning, because I always think back to data centric problems, and that will actually tie in very well to the rest of our conversation today. But a funny anecdote, or a good anecdote, is there's this process when they're completing a horizontal well, which is called the perforation phase. They basically have this gun that goes into the horizontal of the well, and it detonates these charges that perforate the casing so that there's a connection of fluid between the fluid inside of the well and the formation in the rock. So one of the funny things about that was that a lot of the analysts that I was working with in the office, through no fault of their own, had never experienced what the environment was like and understood what the process was like to see those charges go off, when they go off, at what point in the hydraulic fracturing process. So at times when I was back as an analyst, there would be certain signals in the data, certain things about the cadence of certain signals that we were seeing in the acquisition that were kind of anomalous and would be very frustrating, where it would be hard to separate some of the signal from the fractures from those perforations. And having an understanding of how that process goes on in the field really helped me kind of dig through that data in a more efficient way. So that was definitely, yeah. Good, sorry.
That's really interesting to me, because what that tells me is data scientists and people that are working with data analysts, they need to get out and be with the subject matter experts where the data is collected. They can't just sit in their cage, right? In their bubble.
Right.
Because there's a lot of, I guess, what is it, tribal knowledge that goes on by being there.
Right. There's absolutely institutional domain specific knowledge that you can only really acquire experiencing the data environment firsthand. Obviously, there are cases where you can't go out and touch a neutron star. You can't go out and sit on a planet. Yeah, shoot for the stars. Right?
That's right.
But yeah, I mean, there's limits, but for the most part, in my experience in my career, the most impactful technologies that I've seen be deployed into production have had subject matter experts in the domain directly involved in the software development process, either directly consulting at the beginning or just constantly involved in kind of an iterative process. So, and it's also why our users are there too. Users are very important, and because they are the ones directly interfacing with the data environment most of the time.
This brings us to kind of what we want to talk about today, which
Sure.
is, and the whole series we've been talking about generative AI. Generative AI really kind of broke down some barriers between the end user, right, or the person generating and wanting the data, and the data scientists and data ops and all that stuff, by moving it closer, I think, to the end user. But there's some problems with generative AI as well, right?
Right. Absolutely. I think when I talk to folks about why, doing a little bit of brainstorming or trying to explain to family members or folks like why now generative AI has kind of been the proof point of AI and machine learning in general. When I started working in machine learning, which really wasn't that long ago in terms of, like a full, some of the careers that some of the major, leading researchers have had in the field, just 7 years ago, we had, nobody believed in the technology. It was like pulling teeth, trying to convince people to use it. Everybody always claimed the black box kind of paradox and would say, I don't believe in it. It's a black box. It's non-deterministic. We need something that, we can, have proper, it's predictable, or you understand.
It still is indeterministic.
Right. Exactly. But what's changed? And I think it's the modality that's changed. It's the way that people interact with it. because language, specifically text, is such a common and safe and familiar environment to interact with data and with machines in general. I think it has made people feel more comfortable with the idea that these systems are more trustworthy. It has a lot to do with obviously the data that these systems are trained on. They're trained on human created data for the most part. Therefore, the way they interact with you, makes you feel like you're interacting with a human. I was talking to somebody the other day. The timing's great of generative AI in this modality, because if you ever, when you're sitting in Thanksgiving with family, or you're having beers with friends or whatever, and so there's like a debate topic, what do most of us do?
Let's go to Google.
Exactly.
Yeah.
We already had this search answer modality or mechanism kind of baked into us. We already trusted it, and now we've just up-leveled it.
Well, I also think the pandemic had a lot to do with this too.
Of course.
Because the pandemic kind of introverted all of us.
Yeah, sure.
Right? And I watch my kids, they communicate with texting each other, boom, boom, all day long, right? They text you. So they're very used to this language or use of natural language to interact with each other on text. So when GenAI came in with just text, not even speaking yet, it was natural. It's a natural interface that we all work with. So I think you're right. That really broke down some of the barriers to AI. But you talked about modality. All the big, ChatGPT, Claude, what is a Bard?
Mm-hmm.
They're all public. They're all public clouds, right? They're general knowledge type of things. A lot of businesses still don't have Gen AI policies. Some do that say you can't use it at all, which is ridiculous.
Right.
But isn't there some fear of data going into a public Gen AI, a public cloud? It goes back to the public cloud conversation that we had 10 years ago.
Right, exactly. And I think, this brings us to our topic that you mentioned at the beginning, which is, we have mechanisms through which we can, add additional context about private data or institutional data so that we can further augment the interaction with those models through, particularly in this case, the modality of text, right, and natural language.
Wait. I stopped there for a second before. So what I've heard before is I need to go train my own model on my own data.
Right.
So that's expensive though, right? Because that takes a lot of time and resources. I got to go buy, GPUs to do all my training. So I know about that. I've heard about that. And I have a lot of customers that are like going, we'll download the Llama 2 model, we'll train it up even more with our own data. But the cost is huge and the time commitment is large too. That is a barrier again. We hit another barrier.
Right.
But you have a different approach, right?
Right. And it's, obviously full disclosure, it's not my approach. It's definitely something that today is actually very common in it. And like, we talked in the past is probably the most sought after implementation of generative AI. And a lot of people have quoted that 2024 will be the year of retrieval augmented generation. So, what is retrieval augmented generation? And the process through which we can embed some of this institutional knowledge into these systems. If you think about leveraging a large language model on its own as the backend to a chatbot, realistically, you're only going to have access to the knowledge that it's been previously trained on, and potentially not necessarily in the amount of detail that you'd like, because obviously it's trained on a ridiculous amount of data, these massive corpus, and these incredibly large data sets, and it's not going to be particularly talented in any specific domain or anything like that.
It's just it's general knowledge, right?
Really what you get out of a very large language model that has not been fine-tuned or has not been instruction tuned is a very strong language modeling capabilities, for the most part.
So it can understand what you're asking, basically.
Right. It can model language. Once you get into very, very high parameter counts, for the most part, for getting, well past the 70 billion, you do get a lot more, I guess you could say, zero shot capabilities, which means like you're able to get more out of the model without introducing additional context or examples. Like zero shot prompting is like for example, simple, straightforward Q&A. What is, give me a recipe for a chocolate cake, right? That is zero shot. If I were to introduce an example of how I want my answer structured, or an example of different ingredients that typically go into a chocolate cake, then that would take me a further step, and we'd be adding knowledge and context to the model. But in this case, once you get past those large parameter counts, you start to have better zero shot capabilities. But when we're working with the models that most people are going to be working with today, not a lot of people have the infrastructure to support massive models at the 180 plus 100 billion parameter plus.
Or trillion, right? Supposedly ChatGPT 4 has a trillion.
Supposedly, unverified, but yes, exactly. And so in terms of your ability to, circumvent the need to fine tune a model, with a lot of your own data on a lot of infrastructure, potentially, you could use a tool like retrieval augmented generation. And retrieval augmented generation is basically the process of being able to access, using tools like, for example, techniques like similarity search, be able to take a user's prompt and use that prompt to search a private knowledge base for information that is relevant to that user's prompt, combine it before providing it to the large language model, so that large language model now has additional context about that user's question. So, go ahead.
Okay, so I when you said that, in my mind, it came up, this is almost like having a library of books and a librarian that's been there for 100 years. And
right.
Which, as a kid, that's how I thought my elementary school librarian was, right? She knew where all the books were.
Right.
So it's me going and asking her a question, right? I'm asking you a question, and she can say, the answer is this, and you can go find the book over here and read it for yourself. Is that kind of what a RAG model is?
Kind of. I mean, the best way that, I guess, one of the clarifications I'd make is that at this level, if you're just taking a model off the shelf, like a pre-trained model off the shelf, let's say a 7 billion Llama 2 model, and you're pairing it with RAG, with that retrieval mechanism, and adding that context, really you're only depending on Llama that Llama model for the most part for its language modeling capabilities, right? For the most part.
Okay.
You're wanting it to understand the context that you're providing it and the user's question in order to provide a what I call an aligned response. So alignment, when you speak about within the context of large language models and these applications, is basically how close is the output to the intended or expected output that the user or the
Gotcha.
output
So
that the user
they got the
expects
right,
when they provide the input. So, like, is it doing the thing that I expect it to do? Right.
Right. Yeah, that makes sense.
So if you think about fine tuning, if you fine tune a model, you're aligning it. If you instruction tune a model, you're aligning it to a particular domain, a particular use case. Retrieval augmented generation is a type of alignment where you're not perturbing the weights of the model necessarily, right? You might fine tune and use RAG, but in this case, if you're only using a pre-trained model in RAG, what you're doing is circumventing that alignment process that would potentially take place during the fine tuning phase, and just leveraging the context to align the model. Does that make sense?
It does. So the RAG, the data that I gave it in my RAG, is helping to align the model based off the questions that I'm asking, because it gives context.
Exactly.
Okay.
Yeah.
That, to me, that makes sense. So practical use of this, so let's talk about my podcast, for example. This is going to be episode 186. Nice. And I write a blog, and I've got transcripts for all this. I could put all of my transcripts into a RAG, I can use Llama 2 or Mistral or Falcon, one of the other ones. And now I can ask that large language model things about my podcast.
Absolutely. Yeah. Yeah.
Like, how many times did Eduardo come on the podcast? Right.
Right.
It should say one.
It should say one,
and then it'll probably say, but you should have him on a lot more. And then I'll know that Eduardo helped train the model. Right.
So that's right.
What I can get out of this. Right. It will give me information about my podcast, because that was the context that I gave it.
Absolutely. And a lot of those like applications are typically called like chat with video or chat with PDF, is kind of like those are called. So for example, if you take a YouTube video and you extract its, the captions or the transcript, and then you basically think about chunking up that video and attaching a timestamp. Then what you do is you put all of that into your knowledge base, and then based on a user's question, you're going to retrieve it. But for example, you could also retrieve metadata about that specific chunk that you're retrieving from your database, in order so that the user could not only go in and find your answer, but also source where that answer came from, and then go to the correct video and potentially interact with that snippet of, 5 seconds, right, of text or content.
Thanks, Eduardo. And tune in next week for part 2 of our interview with Eduardo on generative AI and RAG models. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.